Okay, so for today's class, we have some past papers for the chapter of forces and equilibrium, and we discussed tension in the last class. We discussed weight in the last class as well. So we are here. Let's do a question. This is a past paper class for this force and equilibrium. Otherwise, the basic things, the logic is all complete. The theory is complete. So right now we have two light inextensible strings attached to a particle of weight 25. So you can see this is the weight of the particle, and the strings pass over two smooth fixed pulley. So look, this is this is a complete one string, and this is another complete one string. Okay, so there are two strings. So the tension over here, this, what do we have? Okay, have particles of weight A and B. So this is another particle. Okay, this is another particle of weight A, and this is another particle of weight B. The sloping parts of the string make angle of 30 and 40 with the vertical. Okay, the system is in equilibrium. Find the values of A and B. Okay, so definitely the force on this part, the weight of this particle is A downwards. So definitely there would be a tension force that would be opposing this weight because the system is in equilibrium, and this would be the tension in this string, which would be pulling it upwards and cancelling out the effect of the weight of A. Similarly, this would be pulling it down like this, and over here as well, it would be like this, and the arrow. The tension in the string would be pulling the 25 Newton weight upwards. Similarly, to overcome the weight of this particle, the B Newton thing, the weight, sorry, the tension in this would be, we can call it TB. Okay, so TB, we know the tension in the string B TB would be equal to the weight of the B newtons, right? This would be B newtons, and the tension in the with the particle A would be the weight A. Because the system is in equilibrium, they are cancelling each other out. There is no resultant force, so they are equal to each other. So definitely this would also be pulling it upwards. This would be TB, pulling down, pulling down. So if you separate this, if you make this diagram again, this would be like this. The weight of this thing is 25, and there are two forces. One of them is over here. This is 40 degree, and this is your TB. Yes, TB. And there's another one like this. This is TA, which is 30 degrees. So you have to find this TB and TA. Those would be the weights, B and A. So you break this down into the components. This would be TB. This is the components which is opposite to the 40. So this would be TB sine 40. And the vertical component would be TB cos 40. Similarly, this would be TA sine 30 and TA cos 30. Now we make the two equations. The horizontal ones, the left one would be equal to the right one. So right is TB sine 40 and left is TA sine 30. This is your first equation. Second equation, it would be vertically upwards. You have two forces, TB cos 40 plus TA cos 30. That is equals to the downward force, which is 25. So you found these two equations, and then now you would solve them simultaneously. So if you make the TB subject in the first equation, it would be TA sine 30 upon sine 40. And then you substitute over here TB. So TA sine 30 upon sine 40 into cos 40 plus TA cos 30 is equals to 25. If you take the TA common, the inside of the bracket would be sine 30 upon sine 40 multiplied by cos 40 and then plus cos 30. So you have taken TA common, and then the answer of this thing, whatever that you've gotten, it goes in the division of 25. So TA would be equal to 25 upon this answer, which is 1.461. So answer of this thing, 25 divided by this answer. This is 17.1. So 17.1 Newton. This is the answer for your TA. Then you can substitute the value of this TA over here. 17.11, whatever that is, multiplied by sine 30 upon sine 40. So you're getting 13.3. So your TB is coming out to be 13.3 Newton. This is your final answer. Okay, so the important thing to understand is this diagram, this free body diagram. We call these free body diagram. When you separately draw all of the forces, this is free body diagram. Okay, do you get it? Any questions?
No, sir, it's fine.
Okay, chalo. Good. So this thing is important. How you work around the tension. You will do, I think, a few questions, and then you will get a better hold of how to form these, how the forces are interacting with each other. So easy 6 marks. Easy 6 marks. Then this one is also, I think, not so very hard. The 4 coplanar forces shown in the diagram are in equilibrium. So this is very similar to the last one. Do you want to try this one? Okay, try this one. I'll give you 10 minutes. You have 10 minutes. Try this. Give me the answer for P and theta. I'll pause the recording, okay? And then give me an answer, and then we'll resume. This is a very repetitive question, so let's see how if we can do it. I'm pausing the recording. Okay, so we think we are getting a little bit of difficulty in solving this. So let's see what can happen over here. First of all, you break them down into components. So this would be your first component, which would be P, and this is the angle, this is the component adjacent to the angle, so P cos theta. And you would have the same P cos theta for the downward as well, P cos theta. For this one, you would have P sine theta. And for this one, you would have P sine theta. For this one, 3P cos 55. And this vertical one, 3P sine 55. So let's see. If you form the equations horizontally, you have 2 forces to the right side, P sine theta and P sine theta. So this becomes 2P sine theta. And on the left side, you are getting a single component, which is 3P. Sorry, this is cos 2P cos theta, and this is 3P cos 55. This is your horizontal things. Now your vertically, the first is upwards 3P sine 55 plus P sine theta is equals to P sine theta, which is a downward as well, plus 20. So P sine theta, this would cancel out. So your P would be simply getting out as 20 over 3 sine 55, which is, did you get the P, Nadia? Is it the same? 8.14.
Yeah, that's what I got.
And now you can just replace the value of P over here, 8.14, 138.
Yeah, I didn't add the cos theta twice for the horizontal equation. That's why.
Okay, no worries. 3 times 2, sorry, 8.138 cos 55. So cos theta would be equal to, this is your answer, whatever this answer is, you are multiplying this 3 times this answer times cos 55 and divided by 2 times this answer, which is equals to 0.86. So theta would be cos inverse of this answer, which is 30.6. So 30.6 degrees. This is your final answer. Okay, that's it. Okay, Murtaza, सही है, clear है? All good?
Yes, sir.
Okay. We have this one also from 9709. This question is from, we did two questions right now from 9709. So let's do a question for Edexcel M1. This is also very relevant. So a particle P of weight 5 Newton. Look, they have given you the particle P, but they have not labeled it. So the weight force is downward, acting downward from here, particle P, which would be 5 Newton. Okay. Attached to one end of a light string. The other end of the string is attached to a fixed point O. Okay, fixed point, that is a fixed point. A force of magnitude F Newton is applied to P. This is a separate, this is a string. Over here we would have a tension, force of tension. And this is simply a force on P. So it's applied to P. The line of action of the force is inclined to the horizontal at 30 degrees. Okay. And lies in the same vertical plane. The particle is in equilibrium. Okay. Everything is given to us. So what do we need? Find the tension in the string. So if we want to apply the simple angle properties, if I extend the vertical over here and the horizontal over here, we can apply the Z property. Look, this is the alternate angle property. So if this is 40, this would also be equal to 40 degrees. And now you break them down. So the horizontal components, you break these down into components. So this would be F cos 30, and this one would be F sin 30. Okay, the component adjacent to the angle is your cos always. So for this one, this would be your tension T cos 40, because this component is adjacent to the angle and this is the opposite to the angle. So this would be T sin 40. Now you form the equations. So find tension in the string and find the value of F. Okay. We will form two equations. Vertically you have T cos 40 upwards plus F sin 30. This is also upwards. Is equals to downward you have 5 only. And then right side you have F cos 30. And left side you have T sin 40. That's it. You have formed the two equations. Now you can solve them simultaneously. This is your first equation. If you reset this equation, you will get T sin 40 minus F cos 30 is equals to 0. This is your equation number 2. And now you can use your calculator to solve them simultaneously. Simultaneous equations. Cos 40 sin 30 and 5, and this would be sin 40 minus cos 30 and 0. So when you solve this, your T comes out to be 4.396 newtons and your F is equals to 3.26 3 newtons. That's it. I don't know why they gave us 7 marks over here. This was an easy 7 marks, isn't it? 7 marks. These are, I think, more than required over here. Okay. Nadia,
Yes.
clear?
Yes,
Sometimes
sir.
the questions are very rewarding over here. Once you'll do a lot of questions, then you will see that the questions are very, very repetitive and easy and very easy. So this is, I think this was one of the very easiest. I think this was, I thought before that it was 7 marks, there might be something difficult, but it was easier than the previous ones as well. This is where they were asking you for the magnitude and direction of the resultant force of the 4 forces. There are these 4 forces and we want the magnitude and direction of the resultant force. At the end of the class, people will do this question. Okay, this is an easy one. This is just, I think, if you don't make silly mistakes in the angles and things, then you would be able to do it easily. So let's keep it for you people at the end of the class. I found another question very relevant to the this Edexcel one, and this is also easy. The 9709 people can also do this one because we know how the things work in I and J, right? I and J, I is simply the x direction and J is the y direction. Vectors, right? Slightly vectors. This is using vectors. I is x direction, horizontal direction. J is y direction. So the components are already given to us. For F1, F2, F3, the particle is in equilibrium under the action of these forces. So if you write F1 plus F2, the force, the sum of the forces F1, F2, F3 would be equal to definitely 0, isn't it? Because the particle P is in equilibrium. So these three forces would be cancelling each other out entirely. So the sum of these three forces would be equal to 0. Now if you write down their what do we say, these column into the column vector, so this becomes 2 and 3a. Plus for F2 you have 2a and b. For F3 you have b and 4 is equal to 0. Now you can form two equations. One for the 0, you can write it down as 0 comma 0, right? It's the same thing. So now you can form two equations. In the x direction, it would be 2 plus 2a plus b is equal to 0. So 2a plus b is equals to minus 2. This is first equation. In the y direction, you can do 3a plus b plus 4 is equals to 0. So 3a plus b is equals to minus 4. This is your second equation. And now you can solve them simultaneously. You will get the values of a and b. So questions can come in for like this for the Edexcel ones, okay? When you have to work for in this column vector thing. So a is minus 2. Sorry. And b is 2. That's it. This is your final answer. Okay. Nadia, all good? Nuba, you are late today.
Yes, but I understand.
Good. We did 2-3 questions. We did this one, this question past paper. This was also past paper question. This is for you people. We'll do this later. And then we did this one and we did this one. This was of 7 marks, but I don't know what was the 7-mark thing over here. So it was very easy. So let's find another past paper. This is again for you people, okay? Wait for that. By the end of the class, I'll give you that one. Let's find a good past paper question, a difficult one, because most of the questions are like this. They are not that difficult. For this chapter, okay? Not for this chapter. For others, we have difficult ones as well. There are many things that we can discuss right now, others as well, but we would be going through all of those things slowly. This is, let's see, a small smooth ring of mass 0.2 is threaded onto a light and extensible string ARB. Okay, this is a good one. Sometimes this question comes in combination with others as well, so we have to carefully choose the ones which we can do right now. Okay, a small smooth ring, you can see the ring R of mass is given to us. So using this mass, we can find the weight. What is the formula for weight? Murtaza? Oh sorry, हाँ weight का formula क्या है? Weight. No one knows the formula for weight.
Mass relation.
mass into gravitational acceleration, mg. So this would become 0.2 times g. G is most of the time right now 10. So this comes out to be 2 Newton, which would be always vertically down. Okay, then the two ends of the string are attached to the light inextensible string. So this is one single string, ARB. ARB is a single string. So I told you whenever it is the single string, then the tension is the same. So tension would be T like this and T like this, the same tension T. A horizontal force of magnitude T acting on the plane is applied to the ring. The section BR, what is BR? Is perpendicular to the roof. Okay. The section AR is inclined as 70. Okay. The system is in equilibrium. Find the tension in the string and the value of P. So we want this P and P. So we have to use a little bit of angle properties. If I make this vertical, so this angle would be 90 minus 70 would be 20. क्या लिख रहा हूँ? 20 degrees. And what about this angle? This would be how much? Okay, this is given to us 45. So if this is given to us 45, then this would also be equal to 45, isn't it? Because of the F property. What do we say that corresponding angles? And if this is 45, this is 90, so this comes out to be 45 as well. So now you have formed all of the angles, and this is what your diagram is looking like. This is 5 Newton. This is tension with an angle of 45. This is also tension with an angle of 70, and this is P. And the rest of the thing is the same. Now you would break them down into the components. Let's bring it over here. Hey. Now you break it down. This becomes T cos 45. This becomes T sin 45. This becomes T cos 70. This becomes T sin 70. And everything else is done. So vertically, if you see T sin 45 plus T sin 70 is equals to 5. You can easily find the value of T from here. And then horizontally you have T cos 45 is equals to T cos 70 and plus P. So from the first equation you can find the value of P. Sorry, T. This would be 5 divided by, if you take the T common, sin 45 plus sin 70. So this is, your T comes out to be 3.04 Newton. And now you can replace it on the left side in the second equation. So this answer cos 45 minus the same answer cos 70. This is giving you 1.108 is equals to P. These are the two answers. That's it. The main problem was understanding this diagram and using angle properties slightly. Okay, all good?
Yes.
Yes, sir.
take a minute, understand it. We'll find another question. We'll do one more question and then let me find a past paper from the Edexcel one. Okay, let's do this as the last question for this class, and then you have one question to do at the end of the class. Okay, the particle P of mass m kg is attached to one end of the light and extensible string of the length. Okay, length of this thing is 2.5 meters. The other end of the string is attached to a fixed point. Okay, A. This is the fixed point A, and okay, vertical wall. The tension in the string is 16 Newton. Yes, you can see the tension in the 16. The particle is held in equilibrium by a force of magnitude F newtons acting in the vertical plane, which is perpendicular to the wall. Okay, contains the string. This force acts in the direction perpendicular to the string. Okay, perpendicular to the string. You can see, given that the horizontal distance of P from the wall is 1.5 meters. So they have given you this thing. This is 1.5 meters. Find the value of F and P. So now we can, using this diagram, we can find the value of this theta, isn't it? For this triangle, this is 90. So you would use cos. Cos of this theta is adjacent upon hypotenuse. So theta comes out to be cos inverse of 1.5 over 2.5, which is 53.13. So if this is 53.13, then if I draw vertical over here, so this angle would be 90 minus 53.13. 90 minus. So this is 36.89. And this would be again 90 minus 36.89, the same as 53.13. And this would be again 36.87. Sorry, this is 87. Okay, now you break down in their relevant components. So this one would be F cos 36.87, and this one would be F sine 36.87. This one would be 16 cos 53.13, and this would be 16 sine 53.13. And the weight value of m, they're asking you to find the value of m. This would be mg. So m times 10 m Newton. Okay, so now you form the equation. So horizontally you have only 2 F cos 36.87 is equals to 16 cos 53.13. So this one would get you the value of F. For the vertical ones, F sine 36.87 plus 16 sine 53.13 would be equal to 10 m. So you can find the value of F from here, 16 cos 53.13 divided by cos 36.87. This is 12. And you input the 12 over here. So 12 sine 36.87 plus 16 cos 53.13. This is 16.8 is equals to 10 m. M comes out to be 1.68 kg. That's it.